So hello guys, in this tutorial I'm going to show and explain what is FPGA, how it works and how it relates to the modern technology, and I'm also going to explain about a tutorial on running some seams in Quartus by Intel. So this video will cover four parts. One part is about what is FPGA, and the second part is about how to use the Quartus and how to run a simulation, and the third part I'm gonna explain types of simulation that we use in Quartus eventually, and the last part I'm gonna explain my output of the program. So without further ado, let us go to the first part. In this first part, I'm going to explain about what is FPGA and why it's the big deal. And here I have a website that I use as a reference, proboscorp.com. I will attach in this video below, comment section. So again, FPGA is a field programmable gate array. So essentially, an FPGA is a hardware circuit that users can program to carry out one or more logical operations. FPGAs are also known as integrated circuits or ICs. These circuits are groups of programmable logic gates, memory, and other elements. These logic gates I will explain later on in the tutorial. So if we Google FPGA here, you can see FPGAs are many manufactured by many companies. It's Altera here, it's the most common one. So this is a visualization of what FPGA is. Sorry. And okay, and in the relevance to these days, FPGA are gaining prominence in deep neural networks that are used for artificial intelligence. Running a DNN or deep neural network models take significant processing power. A GPU itself are often used to accelerate this kind of process, but in some cases, high-performance FPGAs are actually better than GPU, especially in analyzing large amounts of data for machine learning. So Microsoft already used FPGA to accelerate their AI. There's a project named Brainwave that provides customers with access to Intel Stratis FPGA through Microsoft Azure Cloud Services. These cloud services outfitted with these FPGAs have been configured specifically for running deep learning models. So Microsoft Surface lets developers harness the power of FPGA chips without purchasing or configuring specialized hardware and software. So instead, developers can work with common open source tools such as Microsoft Cognitive Toolkit or TensorFlow AI development framework by Microsoft. So on to the next part. In this second part of the video, I'm going to explain how I run a simulation in Quart by using Quartus by Intel. So what I'm going to do is open the application if you have. If you don't have, you can install and search for reference. It's quite simple. So when this pop up here, just new project wizard and name whatever you want. I'm going to name test one and just next. Open the project. Okay, just open project and just wait for a moment. And when this things show up, it means that the project you created has been established. And what I want you to do is go to the file here and create a block diagram file. And next thing, just go to here. Here's information, a little information. This is a symbol gate that we usually use to AND or exclusive or something like that. So just go ahead to this folder, go to primitives, and go to the logic. And you can use anything you want. And just using an AND, one AND here, two AND. I'm gonna use also one OR, and I'm gonna use of four inputs and one output. So go ahead to the pin folder, go to the input, just paste four of it, four, and go ahead to the output and for the output here. So what I want you to do now is go to the head to the selection tool and just match these things first. Just arrange it as your eye suitable to see. And okay, just for now, just make like this. Just okay. What I want you to do is drag this line here and paste it here. Do for all inputs to the AND logic gate, and also make for all of this, including the AND to the OR gate here, also to the OR gate here, and from OR to the output. So okay, as these things have been done, just I need to rename all this to A, B, C, and D, and the output I'm gonna make it X. So next thing we're going to do is just click the run start compilation here. Just click yes and just save whenever you want, and just click save and wait for a while. You can see in this bottom right here it has a 1%. Wait until it's 100% and continue to do the next steps. So just wait for it. So continue. When you have a bottom right here 100% means your file is uh, it's already compiled successfully. And what I want you to do now is go ahead to the file, create a new file of University Program VWF. Just click it and just follow what as I said. Just go to the edit, go to the set end time to 16 microseconds. Sorry, 16 microseconds. And again, go ahead again to the edit, set the grid size to 1 milliseconds, the US. And as you can see, here's a empty waveform. It is suitable to see. Now what I want you to do is to make a save as. Just save whenever you want, just save it. Okay, you can see a new pop-up here. And what I want you to do now is to insert all the inputs and the outputs. How to do that is just right click on this left column, go to insert node, node finder, and just list all things. You can see the A, B, C, D, E, X, and X that I created previously. Just click this copy all to selected nodes list and just click OK. Just OK again, and you can see it is an empty waveform. So what I want you to do now is to just create an input. Just click this and click edit and go ahead to the value and override clock. Just make it 2 for this, just an example, 4 for this. I'm sorry, just go to the override clock again, just make it 4, and so on and so forth until you can until the D here. Just make all things. I use 2, 4, 8, and 16. And as you can see, here's a 2, 4, 8, and 16 have been done here. So what I want you to do now is to go ahead to the save it first and go ahead to the simulation. Just run functional simulation. Just wait for it to finish, finalize everything. Just wait. It may take a few moments. Just wait for it. And here is how the output will be. Here's a functional simulation. There's two types of simulations, functional and timing. I want to explain what's the difference between them, and but just to make sure that the compilation process has been done. Here, this is the functional. This is the functional. This is the timing here. So okay, that's all for this. On to the next. In this third part of the video, I'm going to show and compare what's the difference between functional and timing simulation. So functional simulation is simply test the logic functional operation of a circuit. There is no consideration of delay through the internal logic or the routing delay paths associated where the place and the router interconnect things. But timing simulation consider these things. The delay associated with the logic elements are take consideration on outputs. In this, both this here is the timing, here is the functional. There's no quite difference because it's just a simple input and output. But eventually, when you try in other kind of inputs, large inputs, outputs, you can see the difference. On to the next part on explaining how the result can be like this. As I mentioned earlier that my timing and functional will not cause any different outputs because I'm using a simple kind of inputs. So I'm just explaining from one part. So why is my output like this? Is it true or not? So you know that I'm using an AND logical for A, B, and C, D. So the output will be true or high like this whenever A and B is high, or whenever C and D is high. High means true. So for example here you can see this is true or high because A and B is in the high position. This is true because C and D is in the high position. And this part is all of them true or high because C and D is high from all these parts. So the output is true because it matches the logical gate that I previously put in the file. So this proof that my circular is correctly run, and that's all about my explanation. Thank you for watching.